Hello viewers. So in today's class we are going to learn the geometrical interpretation of this integral, that is from minus a to a f of x dx is equal to 0 when the function f of x is an odd function, right? So let us start. So now let us evaluate this integral, that is from minus pi by 4 to pi by 4 and tan x dx, right? So let us first evaluate this integral with the help of this property. Now here we see that the function f of x is tan x, and if we replace x by minus x, we see that f of minus x is equal to tan of minus x, and tan of minus x is minus of tan x, that is minus of f of x. So we have proved that this function that is tan x it is an odd function, right? It is an odd function. So by this property the direct value of this integral is 0, right? Okay, so we have evaluated this integral with the help of this property, and we see that tan x is an odd function, hence the value of this integral is 0 due to this property. Now let us see the geometrical meaning of this integral, and let us see how the value of 0 is arrived. Now let us sketch the graph of this function fx is equal to tan x. So here we have x-axis and y-axis, and let us say let us take the values here. Say this is pi by 4, this is pi by 2, and here let us take minus pi by 4, and here let us take minus pi by 2. So here we are taking only these two values, pi by 4 and pi by 2, in the positive x-axis, and minus pi by 2 and minus pi by 4 in the negative x-axis, right? So now we know that the function tan x is infinite at x equal to pi by 2 and x equal to minus pi by 2. So we know that tan of pi by 2 is not defined, or it is infinity, right? So here in order to draw the graph of this function, let us draw a line which is parallel to y-axis. Similarly we have tan of minus pi by 2 is also not defined, and let us draw another line which is parallel to this y-axis. So now let us draw the rough sketch of the graph of fx equal to tan x. So we see that the graph, it looks like this, and here we have the graph, right? So this is the graph of fx equal to tan x, and here we see that these two lines, the dotted lines, that is x equal to pi by 2 and x is equal to minus pi by 2, are the asymptotes to this curve, right? Now the value of tan pi by 4 is 1. So here we have x equal to pi by 4, and this value is 1, right? And tan of minus pi by 4 is minus 1, right? And the value, it lies somewhere here, right? So here we have minus 1 and here we have plus 1, right? So now we have to find the value of this integral from minus pi by 4 to pi by 4 tan x dx, right? Now by the definition of integration, we know that integration represents the area under curves. So it implies that when we integrate this function tan x from minus pi by 4 to pi by 4, so it means we have to find this area, right? This shaded area. So evaluating this integral means to find the area of shaded region, right? Shaded region. And here we see that this area is equal to this area. Why? Because this function is an odd function, and the graph of an odd function is symmetrical about y-axis. So we conclude that this area is equal to this area, and moreover, if we represent this area say by a, then this area should be minus a. Why? Because this area lies above x-axis, right? And this area lies below x-axis. So if we add these two areas, right, these two areas, that is minus a plus a, will get 0. So this is how we get the value of this integral equal to 0. So integration means to find the area. So here if we integrate from minus pi by 4 to pi by 4, we have to find the sum of these two areas. Now this area lies above x-axis, so this is positive by convention, and this area lies below x-axis, so this is negative. So we have the total sum as minus a plus a is equal to 0. So that is how we get the value of this integral as 0.